Hello, this is Boston Zachman, and this is ECE461 control systems test number 1. So I have the PLC hooked up here with my structured text program on it. If I hit button 1, the output comes on. If I hit button 3, the output goes off. And if we want to test the counters here first, it's 2, 3, 4, 5, 6, 7, 8, 9, 10 cycles, 11, 12, 13, 14, 15, 16 cycles, and then nothing else after that. And I also set it up so I can clear the counter with button number 4. So we'll move on now and test the automatic mode. We're all the way at 0 volts at the input, and PLC just started up, so now it's in automatic mode. Output is high and continually stays high. That's because we're at 0 volts. We need to be under 2.66 volts to be over 50 degrees Celsius. And now we're at 2.67, just over 2.66 volts. We need to be between 2.66 and 3.48 volts to be between 50 and 40 degrees Celsius. Here it's blinking at a rate of 3 seconds on, 1 second off. And moving on, we need to be between 3.48 and 4.46 volts to be between 40 degrees and 30 degrees Celsius. And so here we're in that mode, and you can see we're at 2 seconds on, 2 seconds off, roughly. And we need to be between 4.46 and 5.55 to be between 30 and 20 degrees Celsius. And in this mode, we're 1 second on, 3 seconds off. And changing the input to be higher than 5.55 volts, we get continuously off because we are under or at 20 degrees Celsius. And there are the scope updates. You can see it's at 0 volts. So here is the voltage and ADC count calculations needed in the structured text program. So here we have temperature in Celsius. It's converted to Kelvin, and then using the equation given in the assignment sheet, we convert that to a resistance. Then using the voltage division equation, we convert that to a voltage at the input pin, and then also to an ADC count. So that's mapping 0 to 10 volts to 0 to 1,000 ADC counts. And here are the results summarized. So we have temperature to counts. So here's my structured text program running on the PLC. This first couple lines here just sets the state of the PLC. I have 3 states running and 2 substates within automatic mode. So the 3 main states are on mode, automatic mode, and off mode. So here this just sets that state. So if it's 0, on mode is true, the others are false. If the input is 1, or if input 1 is pressed, then it's automatic mode, the other 2 are false. And if it's input 2, then it's off mode, the other 2 are false. This next part here, this determines the on-off time of the automatic mode, so basically the duty cycle. So we take the ADC counts here and we store it in this variable temp in counts for temperature in counts. And we first check if it's less than 266. If it is, then we know that it's greater than 50 degrees, so we want to go into a full on mode. So here are those 2 substates here. So what we want to do is make sure when we set to A mode on, we're going to want to go directly there. And also we also want to say that, hey, we're at 100%. So that's what this is saying here. And we set the A mode off to false and A mode 0 to false. If this is false, we know we're above 266, and so we want to check if we're less than 3 48. And if we are, then we know we're between 50 and 40 degrees. And if we're in that state, we want to say these are both false because we're not in full off or full on. And we want to set the time to be 3 seconds on, 1 second off. So that's what this is doing. Similarly here, if these are both false, then we're going to check if it's less than 446. If that's true, we're between 40 and 30 degrees, and we want to have 2 seconds on, 2 seconds off. If all of those are false, then we want to check if we're less than 555, and if we are, then we know we're between 30 and 20 degrees, and we want to have 1 second on, 3 seconds off. And if all of these are false, then we know we're above 555, which in that case it is less than 20 degrees, so we want to go into a full off mode. In that case, we're going to jump right to the substate A mode off, and we're going to flag it as being full off, and then we're making these false as well. Okay, this part of the code, this handles switching between the actual on and off substates. So we have a timer, an on timer here, and the input is if it's in the automatic mode and we're in A mode on. And then after A mode time, which is set with these, we're going to output Q. So here, if Q is on and we're not in the full on mode, the A mode 100, then we're going to switch to A mode off, which is done here. Similarly, in the second timer on, if we're in automatic mode and substate A mode off, then after 4 minus the amount time, so for instance, if it's 3 seconds on, then it would be 1 second off. We're going to switch from off to A mode on. So that just kind of switches those substates back and forth. Here we drive the outputs depending on the state we're in. So if we're in the superstate on mode, we're just going to drive it on. Or if we're in the automatic mode and A mode on, then we're going to drive it true. If we're in the superstate off mode, then we're going to set it to false. If we're in the superstate automatic mode and the substate A mode off, then we're going to set it to false. And finally, here is the counting of the number of cycles on that output. So we have a timer or a counter up here, and we have some falling edge detection going on. So basically, here we're saying if the output is 0 volts and the previous output was high, where that's a falling edge. So that is the input, and the this is a clear, so I set it up so for testing purposes, if I hit button 3, I can clear it. Also, it has a max on-off count. This variable is initialized to 16, so it can't count past 16. It caps out at that. And then this is setting the previous value state. So if the count is between 10 or 15, between 10 and 15, then we're going to set that output to true, output 1 to true. Otherwise, we're going to set it to false. And then if the counter value is greater than or equal to 16, then we're going to set output 0 to true, otherwise set it to false.